All right. Oh my God, this feels strange doing a math lesson after so many weeks of being off. But um, welcome back to all my grade 9 students. If I was to tell you that I didn't miss you, I would be completely lying. Um, my routine and your routine are probably very similar. You might not enjoy the math as much, but you certainly enjoy the personalities and the people that I get to work with. And before we start in today's math lesson, I want to say that I do miss all of you and hope you guys are staying safe and that when this is all over, hopefully in May we can go back to school and we can have a pizza party or something and celebrate being around. So, with that said, we are going to do some reach backs over the next couple weeks, and we are going to try, hopefully, um, within the next little while, of trying to learn those chapters that we didn't get a chance to study. I know we kind of left halfway through linear relations and we didn't graphing linear relations and that we didn't get a chance to assess it. So we might try and finish that one up somehow. And you know that I love circle geometry, so hopefully we'll get a chance to do that as well. But with that said, today we have 6 questions, and the way we're going to do this is if you go to this little website here, or sorry, you just type in this web um, address, I guess, web page address. I've made it a lot smaller, so tinyurl.com, SJNUW8Z. What it'll do, if I click on that, I think I can do it, but we'll see if it screws it up too bad. It should take you to, um, oh, that's not going to be what I want to show you. I'm going to close that over there. It'll take you to, and I know this doesn't fit perfectly, but a PDF version of the 6 questions we're going to do. So if you want to go there now and download the copy, you can work from there. And if you don't have to download it because what we're going to do as well, if you just wanted to take one question at a time, what I'm going to do is I'm going to put one question at a time up. You can work it out. You can press pause on the video, work out your answer, and then you're going to compare your answer to mine. So if you want to do all 6 right in a row, then you could go to that URL, get the copy. You don't have to print it off, but you can just look at it, do the questions, and then watch the video if you'd like. Or alternatively, if you want to just watch one question at a time, press your pause button on your computer and then press unpause and watch the solution and see if you did it correctly. And if you did, you're doing fine. And if you didn't, what you need to do is just kind of take a sticky note or a post-it note and on your piece of paper make a note of the things you're doing wrong or you're forgetting to do. And hopefully the next time we do a review, you won't make that same mistake. Okay? So with that said, here's question 1. It's from chapter 2 on rational numbers. If you'd like to press pause right now, give it a go, and then when you're ready, press unpause and I'll give you the solution. Okay, well, we're back. So hopefully you press pause and we're ready to roll. So this is a 2-operation question. There's an addition and there's a multiplication. And the first thing you should have realized is that when you're given those things, you have to use BEDMAS, right? When you have more than one operation, you need to use BEDMAS to solve. So with that said, the first thing we're going to do here, according to BEDMAS, would be our multiplication. So I'm going to bring down, I'm going to bring down my 3/5. I'm going to keep it right there. And to that, I'm going to add the product of 1/2 and -1 1/3. So in order for me to solve that, I know that the easiest way to do it is to change my -1 1/3 to an improper fraction. And of course, if you ask yourself, -1 would be 3/3 plus another 1/3, that's -4/3. So once we've written it like that, there's 2 things you can do. You can simply multiply your numerators and multiply your denominators, or as we talked before, you could cross reduce. I'm going to cross reduce by dividing both of those terms by 2. I'm going to get -2/1. And when I do that, I'm going to end up with -2/3 as a solution for the product, which is going to go down here. Now, if you didn't cross reduce, and I'm just going to go back in time real quick. If you didn't cross reduce, which is okay, you would have ended up with -4/6 when you multiplied it all out, which is not lowest terms, which will reduce down to, because both are divisible by 2, -2/3. So you still would have got -2/3 if you didn't cross reduce, but if you did, bravo on you. So once we did that, we now end up with 3/5 plus negative 2/3. And now we're adding fractions, which is a little bit different than multiplying because, of course, in grade 7 you learned that when you add fractions, you need to use a common denominator. The common denominator we'll use for this will be 15 because it's the first shared multiple that 5 and 3 have. And then we're going to create equivalent fractions. 3/5 is equal to how many 15ths? We know that that is 9/15. And negative 2/3 is equivalent to negative 10/15. So instead of adding 3/5 plus negative 2/3, we're going to add 9/15 plus negative 10/15. Once we have that, we know we're going to add the numerator. Oh, sorry, that's a positive 9. We're going to add the numerators and keep the denominator. A negative 9 plus a positive 9 plus a negative 10 is a negative 1. And therefore, your solution to this question would be negative 1/15. So I guess the key points to this question are you need to make sure that when you do multiple operations, you follow BEDMAS. When multiplying fractions, it's okay to cross-reduce if you want, and it's okay not to cross-reduce if you want. Just make sure that to keep your question simpler, it's always easier to use fractions in lowest terms because your numbers are a little bit more manageable. And when adding fractions, you need to have common denominators, and the key to most people that would probably forget, a lot of people would forget this, is that when you are adding fractions that are positive and negative, and you combine the numerators, you still have to use your integer sense by combining positive and negative numbers. Question number 2 is from chapter 3 on exponents. If you'd like to press pause now and try it, you can. Or if you've already done it, I'll show you the solution in just 1 second. All right, so for chapter 2, we have 4 different exponential forms that we're asked to solve and show your work. So we need to simplify it. We need to change it from exponential form into standard form. So the first part says 3 to the exponent of 0. That's not what I want. I want 3 to the exponent of 0. And way back when, we learned that any base to an exponent of 0 is always equal to 1. And the reason why that is we looked at patterns. And if you forget that, you can go back and look at the video on exponents of 0. But just to clarify, any base to an exponent of 0 is 1. So when I change that to standard form, 3 to the 0 will be 1. And I'm going to add that to 1 to the exponent of 5. Now remember, what an exponent means is you take the base and you multiply it by itself the number of times that the exponent is. So in the case of 1 to the exponent of 5, that's going to mean 1 multiplied by itself 5 times. 1 times 1 times 1 times 1. No matter how many times you multiply 1 by itself, it will always equal 1. So 1 to the exponent of 5 is standard form 1. Our next 2 questions, our next 2 parts to it are negative 2 in brackets to the exponent 4. And what that means is when I think about negative 2 in brackets to the exponent of 4, what that really is asking us to do is take the negative 2 and multiply by itself 4 times. So negative 2 times negative 2 is 4, and 4 times negative 2 is negative 8. And negative 8 times negative 2 is a positive 16. So negative 2 base exponent 4 is a positive 16. So I'm just going to add 16. I could put plus a positive 16 if you wanted to, but you don't have to. Right, let's take that away. And finally, the last one is plus negative 2, not in brackets, exponent of 2. And remember that this is not equal to this. We said that if your exponent is not outside brackets, it means it's not a part of the base, which means this is really interpreted as being the opposite of 2 squared, or negative 4. This would be a positive 4 over here. So in standard form, the opposite of 2 squared is 4, so the opposite of that is negative 4. And when we combine all this out, you're going to end up with a positive 14 as your solution. Now, I know this is pretty tough because if you have questions or you've made mistakes, again, I don't have the ability to answer your questions as I'm doing the video, but make sure that if I said something that you're like, oh yeah, I remember that now, just make a little note of it. Either use a highlighter or a post-it note and put it on your question itself. And then next time we do it, have this piece of paper available to you and you can review the mistakes you made last time, and hopefully you won't make them every time. Your third question is from chapter 5 on adding and subtracting polynomials. And we have 2 trinomials. And remember, a trinomial, just to review real quick, has three terms, and this one here has one term, two term, and three term, and it's all in brackets. And to that, we're going to add another three-term trinomial here. And when you add two trinomials together, or when you add any polynomials together, oopsie daisy, oopsie daisy, oopsie daisy, there we are. You're going to simply combine like terms. So adding polynomials is the same thing as combining like terms. And remember, when we did this, if we think about this as being 2x squared, and this being 2x, and this being negative 1. And to that, we're going to add, oh, not shaded in, oopsie daisy, a negative 3x squared. Now, I'm not shading them in because they're negatives. And a negative 2x, and I'm not shading them because they're negative. And a positive 4, and I'm shading them in because they're a positive. When we combine these, what we're really doing is kind of like algebraic zero pairs. So these two positive x squares and these two negative x squareds cancel each other out, leaving me with just a negative x squared. These two positive x's and these two negative x's combine to make 0, or an algebraic zero pair. And this negative 1 and this positive 1 cancel, leaving me with 3. So when I model it, what I end up with as an answer is negative x squared plus 3. Now, obviously, that was what you learned to understand how to combine polynomials, but then we went to simply looking at like terms and saying, well, 2x squared, and its like term is negative 3x squared. So if I combine those, I'm really combining the coefficients. And a positive 2 and a negative 3 make a negative 1x squared. And we said that if it's a negative 1, you don't need a coefficient of negative 1. You can simply call it a negative x squared. Combine the next two terms, a positive 2x and a negative 2x make 0. And a negative 1 and a positive 4 make positive 3. Same answer when we add them together, you end up with a negative x squared plus 3. That was a pretty easy question in terms of adding and subtracting polynomials, so probably most of you got that right. As we start making a little bit more difficult reachbacks, we're probably going to start to combine adding polynomials and multiplying polynomials in the same expression to try and make it a bit trickier for your brain to process what you're supposed to do with each. But right now, that's a pretty good warm-up for today. You've been off for 3 weeks or 4 weeks, so your brain's not quite ready to get back into really deep work. Question 4 comes from chapter 7, which is multiplying and dividing polynomials. Again, it says solve and show your work. So here we really have a monomial multiplied by a trinomial. And remember, if there's no operation between the monomial and the bracketed polynomial, it's implied to be multiplication. So once we know that, we're going to use this idea of distributive property to multiply every term of that trinomial by negative 3x. And if you wanted to, you could have written it out as negative 3x multiplied by 2x squared, and negative 3x multiplied by negative 5x, and negative 3x multiplied by positive 3. And really, that's what your brain is processing. It's processing those three multiplications together. And when we multiply the first one, if I think about this first one right here, what does this mean? Well, it means a negative 3x is a negative 3 multiplied by x, and 2x squared is a 2 multiplied by x squared, which is really an x multiplied by x. So when I think about what negative 3x multiplied by 2x squared is, it's really the product of those three. And we said that the order in which you multiply terms together does not affect its product. So if I multiply first the numerical coefficients, negative 3 times a positive 2 is a negative 6. And x times x times x exponentially, we can express as x cubed. So when I multiply the first one, negative 3x multiplied by 2x squared, I end up with 6x cubed. With the next one, using the same method that we used, I'll write it out because I'm not lazy, but if we think of it like this, multiply the coefficients, you're going to have a positive 15, and x times x is going to be x squared. And the last one, even though you shouldn't have showed your work like this, you're going to end up with a negative 9x. So ultimately, all of this stuff that I'm going to highlight here in green, all of this stuff here, you didn't write. You didn't have to write all that green stuff. All you had to write was what's underneath it. But your brain was processing the same stuff that I did in the green there, right? And you ended up, as a final answer, of this. Negative 6x cubed plus 15x squared minus 9x. Your next question, question 5, comes from chapter 8, which is solving linear relations, aka algebra. So in this particular question, we have, let me just pull up my highlighter again. We have a coefficient of 2 on our x. We have a constant of a positive 3/5. And we have equivalent value of 1.5 on the other side. So back in grade 7, when you were dealing with two-step algebraic equations, you remember that the easiest way to solve them, or the most basic way to solve them, is to simply get rid of your constant first by applying its opposite operation, and then get rid of your coefficient second. So going back to a grade 7 math problem, what I'm really going to do here is I'm going to subtract 3/5 from this side to create a zero pair, and I'm going to be left with 2x. Now if I subtract 3/5 from one side, I have to subtract 3/5 from the other side. And what I end up with is a grade 7 fraction question, a mixed fraction take away a proper fraction. Easiest way to do it is to convert your improper fraction to your mixed fraction to improper. Find your common denominator. Make your equivalent fraction. So here I would have multiplied both by 5 to give you 15/10. Here I would have multiplied by 2 to give you -6/10. So the equivalent fractions are these. Subtract your numerators to get 9. Keep your denominator. You end up with 2x equals 9/10. Now the next part's a little tricky, but not too bad. This is 2x, which means multiplying by 2. So the opposite is dividing by 2. Okay, so I'm going to divide this side by 2, just like I would have in grade 7, and I'm going to get x. But over on the other side, I'm not going to show dividing by 2 this way, right? I'm going to show dividing by 2 this way. And when I divide a fraction by a whole number, we learned that you can create the equivalent or the same answer by multiplying by the reciprocal. So instead of doing 9/10 divided by 2, and remember 2 is really 2 over 1, I can keep the first fraction, change the operation to multiplication, and use the reciprocal of 2, which will be a half. And when I multiply that out, 9 times 1 is 9, 10 times 2 is 20. That is lowest term, so your answer is 9/20. Again, if you did this question, I know there's a lot of work there, and it's very difficult to do when I'm not face-to-face with people that you can slow me down. But make sure that you take a post-it note, make notes where you made your mistakes, and hopefully next time you won't make that same mistake. And finally, your last question is your inequalities chapter. If you want to take a time and press pause right now, remember that you have to graph your solution, so you're going to need a number line for that. Okay, so the first thing we're going to do is we're going to solve this like we normally would, like if it was an equal sign instead of an inequality sign. So we're going to add 4 to both sides. And when we do that, we end up with negative 2x is greater than or equal to 14. Okay. Now, I shouldn't start off with a real tricky question, because when isolating here, we're going to divide both sides by -2, right, to isolate the variable. And the problem with that is remember when we did inequality, we said if you multiply or divide both sides of an inequality by a negative value, you have to flip your sign in order to maintain the inequality. So the solution to your question will be all values less than or equal to -7. And when we think about what that looks like on a number line, I'm going to put -7 there, -8 there, -6 here. All values less than or equal to. That's going to be a closed boundary. Remember, if it was just this, it's an open boundary. If it's this, it's a closed boundary, meaning you would include the value -7. So I'm going to use a different color. I'm going to use red. So all values less than or equal to -7 would be starting at -7 and including, and any value to infinity less than -7. Okay. That's a lot of work for somebody who hasn't done math for quite a while. If you did well, great. If you didn't do so well, don't worry about it. We'll get better at it. For those of you who would like some more difficult math, in the comments below, just request some different questions, and I can help you get some more difficult questions if you want. Or if you're okay taking it slow, that's great. But thank you guys for tuning in. Remember, wash your hands, listen to your parents. Your boomer parents are just trying to help you out. I know my kids are being driven crazy by their boomer parents, but hopefully everything's going well with you. And I look forward to when we can finally see each other face to face.